Good morning, guys. Today we're going to talk about desiccants. And so this is our desiccant edition, and going to put it in a little bit of a Jeopardy format, maybe just to make it interesting. I'll first say if I sound funny, I've lost a little bit of my voice, so I'm going to try to muddle through this thing here for a few minutes. But I always have a lot of questions about desiccants. Everybody's used to working with the refrigerant dehumidifiers and LGRs and regular dehumidifiers and stuff like that, but sometimes not as familiar with desiccants. So today we're going to talk a little bit about those and try to clear up some questions and go from there. We're going to try to cover some about how desiccants are made and how they work, and do's and don'ts, and monitoring, and different types of desiccants that you may use. So let's start with some different categories. We're going to talk about definitions of desiccants. We're going to talk about parts you use, parts, and then we're going to talk about different uses. Why use a desiccant when you have a refrigerant available? When does a desiccant become the best tool to use, and when is a desiccant really not very useful to use? So we want to talk about all of that today as we go. First place on the desiccants, on the definitions of it. Desiccant works a lot different than a refrigerant dehumidifier does. A typical refrigerant works by sort of like an ice machine. The coils on the machine collect water. As water flows over the coils on an ice machine, it freezes the ice to the coil, and then at some point the mechanisms reverse and melt the ice, and the ice drops off into a container below, and you shovel the ice out and enjoy your drink. A refrigerant dehumidifier works much the same way. You pull wet air in over the same coils. The same coils forms that wet air into frost or ice. And once the ice gets so deep, the mechanisms kick in and they reverse the hot gas in the refrigerant and run it backwards through the coil system, heating it up and melting it. Then it melts, it falls down into the tray that you pump out in your little clear tube. Now, a desiccant's not going to have water running out of the desiccant. A desiccant's going to put out hot, dry air, known as reactivation air. And we're going to talk about how that works here in just a little bit. The desiccant works by bounding moisture with a materials such as silica gel. Could be one material. There's other materials as things progress that will come out, but there's cartridges, there's gels, there's powders. There's a lot of different materials that are made up into a desiccant wheel. Those materials are designed to bound moisture to them until the process takes place to remove that moisture. A desiccant, what is a desiccant? It's a big drying machine. It's just a big dehumidifier. I often get asked, well, if I use desiccants, do I still need air movers? And the answer to that is most certainly you still need air movers. Desiccants, just as a refrigerant, is designed to dry the air. The desiccant does not dry a building. It don't evaporate moisture out of building materials. It simply dries the air. Now, it will dry considerably drier than a refrigerant will, just by the nature and the design of it. You should get much drier air out of a desiccant than you would out of a refrigerant. That helps the air dry faster, and a lot of the times helps the building dry faster. What are the major parts of a desiccant? Here's a little bit of a cutout of a type of desiccant, but as you're going through, you'll have moist air that's interjected into the desiccant. once your air is return air inlets as it's shown on this picture here. So you pull your moist air, usually coming from a big desiccant tube that comes out of the building, and you want to pull that moist air into the desiccant. Once you pull that moist air into the desiccant, it'll go through the wheel or the rotor, and it's that red piece in the middle of this picture here. And when it goes through that wheel or rotor, the moisture sticks to that silica gel and it sticks to that compound. Then as the desiccant rotates, there's a chamber in there to where you have extremely hot air, somewhere in the 300 degree range. And that hot air blows that wheel dry, and it blows that dry air out into the wild blue yonder. So you have your reactivation air, that would be called. So that wet air goes out back out into space. Most of the time that's going to measure between 180 and 280 degrees, and it will be just totally off the chart on relative humidity. A lot of times if it hits an object that is particularly cool close to it, it'll actually form water droplets on that object because the air is so wet. So that goes back out into the wild blue yonder. Then as the wheel rotates around a little bit more and you've dried that air out, that wheel out with the heat, then the other blower brings the air back through, and that is supply air outlet, known also as processed air. So once your processed air goes out, that's your real dry air that you would pump back into the building. You'll hear people talk about positive pressure with a desiccant sometimes. That's simply when you do not hook your return air in and you're drying the outside air and you're pumping it into the building without having a return. When you hook your return up, you're drying the air in the building over and over and over again, in the hypothesis that it should be getting drier and drier and drier inside the building. An application to run positive pressure may be to, you've got really dry air outside, but it's cold air. So you want to take advantage of the dry air that the atmosphere and the good Lord has created, and you want to just use that dry air that's already there and heat it up. Could also be done even if the air is dry and it's not cold, just to process it through the desiccant. You may have security concerns. You just can't open the windows and walk off and leave a building to dry on its own. So little different reasons to use positive pressure on one. So there's another slide here that shows you a little about the desiccant and how it works. Your air in, your reactivation air comes into the wheel. Again, it adds heat and through the rotor in the wheel, and it goes out as wet air, and then your process air coming in goes back through, and now it's dry air. So a little bit of science and technology to it, but it's basically in the nutshell how it works. This is very seldom seen, but there are some on the market, and you'll hear some people talking about a hybrid desiccant. This desiccant hybrid setup here actually works with a desiccant wheel and a rotor and a small amount of heat, but it also has a little bit of condensation factors to it as well. That would work pretty much like a refrigerant dehumidifier that I talked about a little bit ago. So on the right side of this screen where you see cooling and condensation, and then you see the water drips into the tank, that would be the part of it that's acting like a refrigerant. In the middle of the screen and over, you would be seeing your desiccant rotor absorbing the moisture after it's condensed and after it comes out of there, and then putting it back into the building. The advantage to this is the air entering back into the building is a good bit cooler. So if you're drying a building in a hot environment and you really don't want to heat the building up more and more, then a hybrid like this would help to cool the air some, or at least keep it from getting hotter from the heat of the desiccant. Normal heat coming out of a desiccant going back into the building is going to range anywhere from 120 degrees to 180 degrees. That's just going to depend on where the thermostat is set, what the outside conditions are, and what the air coming into the desiccant from the building or from the outside, what the temperature of that area is. So it can have a pretty wide variance of it. This is a desiccant dehumidifier that's shown in the picture up here. This particular unit is a little video I'm going to show you, and I'm going to have the gentleman in the slide, Mr. Chaz Bolton, there to point out a few things. And these machines are loud. They're extremely loud, so it's hard for Chaz to narrate while he's pointing at stuff. So we're going to do that narration part for him. Again, the first thing you want on any machine is safety. So have your emergency shutdown. This machine also is fired off of gas, and we're going to talk about different types of machines in a minute, or it can run strictly off of electricity. Shows you your rotations on your motor, so make sure you're blowing air where you want to blow air instead of pulling air from other places that you want to pull. This is your reactivation air that we talked about, your hot wet air, to where it blows it out into the wild blue yonder and lets it go. So your control panels over here, not extremely safe to open these while power's on. You're dealing with 480 volts of electricity inside this panel. And as you can see, looking in that switch box, it's a very complicated setup to make these machines do what they do and to keep the safety devices working. So here's where your return air is. This particular machine has 2 return airs, and because of the temperature, they've got one of those blocked off, and they've got return air going into the other. And they've got your other motor that shows you your rotation there and your react air going out. So you'll notice those little dampers on some of those. Those are to choke that air down and make it stay in the machine longer if we wanted to, or to open it up and let that air escape a little bit quicker. And that's so we can adjust the machine based on the outside temperatures, based on sea level or elevations, and several different adjustments to get the air a little bit drier. So just a 30-second view of the desiccant from the outside. I know when Chaz is standing there, you can also see the size of the desiccants. That package is actually one of the smaller packages, but stands about 7 foot tall and about 9 foot long and 4 feet wide, so pretty good size. So let's talk about when we will use a desiccant. When is it necessary? The larger the building, the more likely that you would need to use a desiccant. And a lot of that is because of power consumption. You start plugging in 100 LGRs into a building that are pulling 8 amps a piece. Now you're pulling 800 amps out of the building that already is designed for an electrical load of what the building is already doing, which is creating a decent atmosphere, and they got lights and they got all kind of appliances in buildings, and some electrical engineer somewhere has figured that it's going to take about 650 amps to run this building, so they would maybe put in 1,000 amp service going into the building and everything runs fine. Well, if you come in there and put 100 LGRs in it at 8 more amps a piece, now you're robbing 800 amps off of that 1,000 amps that's available in the building. So where do you get the extra electricity? The first thing somebody'd say would be a generator. And that's a good answer, but when you get a generator, how do you plug up to the generator to run LGRs or typical refrigerant dehumidification? And the answer is you have to have distribution. Now, your distribution system, made up of cabling and junction boxes and spider boxes, commonly called, is a very good option, but they come with their own set of problems. Number one, now you've got a lot of electrical cables and spider boxes sitting around in the floors, typically in your hallways, and if you're doing any demolition, they get in the way pretty easy. Number two, it's fairly time consuming to get all that stuff set up, especially if you have a long run as shown in this picture. So that's another reason you want to look at that. And the third and last reason, is very expensive to run all that distribution. So doing all that just to get dehumidified air, and in that case a desiccant would be useful because you put one generator on the desiccant. It may already be delivered as a package, or they may be delivered individually, but you put one desiccant on the package, it runs the desiccant dehumidifier, and your dry air is taken care of. Now you can share that extra available amperage inside the building to run your air movers, and often you won't have to have a extra generator to run those. Or let's reverse the situation a little bit. And what if you don't have any power in the building? It's a hurricane, the power's knocked out. It's an ice storm, the power's knocked out. So now you don't have any power. So with the desiccant, you're not only adding using the power of the generator to run the desiccant, but you're adding heat. Remember, I told you it would blow between 120 and around 120 degrees on the desiccant, up to 180 degrees. Well, that's extra heat you're pumping into a building. So that's particularly important during the winter if you don't have any heat in the building because of power losses. So the desiccant sort of gives you two bangs for your buck there. It works as a heater and it works as a dryer at the same time. And then last but not least, if you're trying to load a large commercial building with LGRs, sometimes it's too time consuming. This particular one, you see the yellow hose in the center of the slide at the bottom is coming from somewhere a long way away. And that's because the snow was so deep you couldn't drive up to and around the building, and it was just a long way away to get to the building even from a desiccant. On this particular job, a desiccant was actually set on top of the snow, and the heat from the desiccant eventually melted that snow, and it was about 6 feet deep where the desiccant was setting. So you want to take those things into consideration, but if you were having to roll those LGRs through that snow, it would be a pretty good task to be able to do that, or to get them into the building with no elevators or very little power in there. You come to some other areas where desiccants might not be as advantageous. Would be if you have an air-conditioned building, such as that's in operation, such as a hotel room. A lot of times hotel rooms need to have the doors shut and need to stay a little bit of privacy there. People's got individual stuff in there, so sometimes you might look at that and determine, do you need a desiccant, or will an LGR, work just as good for it? A little bit of different takes on it. Let's talk sizes and types about desiccants. There's all different sizes on desiccants. There's all different types of desiccants that you can choose from to make it available. Desiccants start as small as 325 or 350 CFM, and they go as big as 25,000 CFM. So it just depends on the manufacturer and how big the desiccant is. Typically, most of the time, if you order a desiccant to come out on the building, it's going to be somewhere between 5 and 10,000 CFM, although there are some larger ones in the industry. A good rule of thumb, and only a rule of thumb with sizing a desiccant on a building, is a 5,000 CFM usually will process about 20,000 square feet of building. Again, that's a good rule of thumb. If you've got a doctor's office building with 1,000 10 by 10 rooms, then that's not going to be enough desiccant. If you've got a big box store with no walls in between and limited carpeting in it and a steel ceiling, that's probably a little bit too much desiccant on it. But again, a rule of thumb, somewhere around 20,000 CFM per 5,000 square foot desiccant. There are calculations within the ICRC for desiccants. They're going to lean on the heavy side of desiccant usage, so they may have you putting 2 or 3 into 20,000 CFM depending on the calculation that you use. I certainly will not argue with that, but I'm just giving you the good rule of thumb when you pull up in the parking lot at 2 o'clock in the morning and say, how many desiccants can I use or do I need to use on this job? Then that will give you a good idea. Desiccants are measured, the size is determined by airflow. As you know, on a conventional dehumidifier refrigerant, they are rated by pints. How many pints of water will that refrigerant process at 60 degrees and 60% relative humidity, or 60 and 70? I forget for the moment exactly what the temperature ratings are on those when they're testing them. But anyway, they're rated at pints per minute. The desiccant dehumidifier is rated in CFM, or cubic feet per minute. And what that's saying is how many cubic feet of air is that desiccant processing every minute. So a 5,000 CFM would process 5,000 cubic feet of air per minute. Now, do you want to process the air 1 time an hour, 2 times an hour, 3 times an hour, maybe even 4 times an hour in some extreme cases? So once you decide how many times an hour that you want to process the air, then you can do your math and your division and figure out how many CFM of desiccant that you will need. Again, that's getting a little more technical than the rule of thumb way of doing it. So again, they come in small ones, they come in trailer mounted ones, and they come in large ones. But to do your CFM calculation, you simply take your cubic feet and divide it by the amount of minutes you want to turn the air. So if you wanted to turn it 3 times an hour, you want to turn it every 20 minutes, so you divide your cubic feet by 20. If you want to turn it every 2 hours, it's 30 minutes, you'd want to divide it by 30. And that tells you how much CFM of desiccant air that you're going to need. A lot of questions every time that I get a phone call about how big of a generator do I need and how much fuel do I need. And it's about like going to the hardware store and saying, I want a piece of rope. And the guy says, how long do you want it? And you don't know the answer. It's how long is a piece of rope is the answer to this. There's a lot of varying factors. Desiccant dehumidifiers are basically, all of them have motors on them that turn air. They're blowers, they're fans, they're whatever you want to call them. But you'll have usually 3 blowers on every machine for your reactivation air, your process air, and your intake air. Some machines have 4 motors or blowers on them. Each blower is connected to a blower motor, so you don't have one motor running 3 or 4 blower wheels. You have one motor per wheel. All of those are run by electricity. The part that takes the most energy is your heat source. So what is your heat source? What's heating the air? Remember I told you the heat coming out on your reactivated air is going to be somewhere in the well above 200 degrees range. And it takes a lot of heat to get air that's running at 5,000 cubic feet per minute to heat that air up to 200 degrees or even above. So it takes a ton of heat to go in there. Usually somewhere around 350 to 550 BTUs of heat. British thermal units is the way that is calculated. So let's say you have a reactivated electric desiccant. The red one in the picture is an electric desiccant. Then your burners are going to be electric strip heaters. These same strip heater, you have an electric heater in your house, only much, much, much larger. And then you'll have banks of electric heaters. This particular machine will probably have 6 banks of heaters in it, and depending on where you set your heat thermostat at and your heat levels, how many of those banks will run. That obviously will also be contributed to by outside air. If you're in Lake Charles today, the outside air is 100 degrees. You won't need as much fuel to get that up to temperature as you will if you're in Colorado and it's snowing and 30 degrees. Then you would need a lot more heat. So to run a 5,000 CFM with reactivated electricity, probably looking at about 150 kW generator, give or take. Depends on the manufacturer of the machinery, but somewhere in that range, about 150 kW. Now to the left there, we talk about a propane gas unit. Once again, you still got to have a generator to spin the motors, but once you spin the motors in a gas unit, then it's up to the propane to have a propane heater in there to make all the heat you need. So you'll need a lot less electricity, but then you'll need propane gas to run the heaters. Then you'll see the diesel-fired heater in the middle, pretty much the same as propane, except the heaters are ran by diesel fuel and an oil burner. Much like an oil burner that you'd see in an RV is the best way to describe it. A propane burner in an RV where you see you light the gas and it has a combustion chamber and the diesel goes into that chamber and it heats the air around it. Well, with a diesel-fired unit, doing exactly the same things you are with propane, except you're doing it with diesel fuel. On the bottom left corner of the slide, you'll see a dual-fired unit. What that simply means is this unit will run on propane or electricity, either one. So it's got heater banks built into it. You can cut it on heater banks, or you can hook it into propane, either one you want to do. So those machines come in handy if you're working in an area that does not allow propane. An example of that would be Houston, Texas. If you're inside the inner loop in Houston, you can't carry any propane inside the inner loop. New York City and New York City part of it. Now, places in New York you can carry propane, but you can't carry it on the island into New York City at all. So it depends on the geographic location of the machine you're using. You may not be able to use propane there at all. So the purpose of the dual-fired machine is to be able to use it pretty much anywhere that you need to use it. So now, on electricity demands, if you're heating with diesel or propane, then your generator demands are going to be somewhere around 45 kW or a little less on a generator to spin all the motors. And then, of course, you buy either diesel or propane to operate the burner on it. Again, with the all-electric unit, somewhere around 150 kW to run it on all-electric. The one advantage to all electric, much simpler operation. It's like the furnace in your house. You plug it up, you switch it on, and you watch it operate. Very little maintenance and troubleshooting with it. With propane and diesel, you've got to deal with burners. When you're running these up and down the road, they can get finicky and fidgety, and you get air in the lines and this, that, and the other. You get dirty diesel fuel, clog the diesel filters, so they have a little bit more maintenance to them and a little more finicky to operate. The other side of the bad on the reactivated electric, the generator to run that's going to weigh about 10,000 pounds. The generator to run the propane or the diesel is going to weigh about 3,000 pounds. So when you're looking at hauling stuff on the back of a trailer, depending on which trailer you had, that's a lot of weight difference. And we've had a slideshow before, a presentation on your commercial driver's license and the stuff you've got to have for that. That's a different slideshow, but you have to consider those things when you're looking at what am I buying and how do I want to operate it. Some of it will also depend on your expertise in the field of motorized equipment like that also. With your fuel type, transportation is sort of what we was talking about. Hazmat, when you're pulling propane, you got to follow a certain amount of rules. You can't put a 350-gallon propane tank on a trailer and haul off down the road. You can haul 100 gallons and be within the legal limits, but you have a lot of different regulations from the federal government and some state and local regulations when you're dealing with propane. When you're dealing with diesel, not hardly as many regulations, but a lot of weight. You have a lot more weight with diesel than you do propane. When you're looking at the weight of diesel and the tank that encompasses the diesel, just average it out at 10 pounds per gallon for the weight of the diesel and the tank. So if you're carrying 1,000 gallons at 10 pounds a gallon, that's 10,000 pounds of weight that you're carrying. So usually you can't use a tank that big. You're going to stay down into the 200 gallon range, somewhere in that, not to overweigh something. So a lot of different decisions on your transportation, your size of your trailer, and your available power sources that you want to consider if you're considering the purchase of one of these fine units. Setup monitoring. Setup of a desiccant is different than setup of an LGR or refrigerant. It is a little more difficult than setting a refrigerant. I would not say it's any more difficult though than setting 100 refrigerants. Probably be a little easier. You've all seen the big yellow tubes running up the sides of the building that come out of these. You cut a plywood template, put it inside the building, run it in, and then you run lay flat ducting to put it in and guide it into the building where you want the most dry air. So setup is a little more time consuming on the front end, but a lot less on the back end. And monitoring is, with any drying job, is pretty much a constant process that needs to be done to make sure it's operating correctly. The process there to get your setup and get your desiccant started is the dry air that you're going to be putting into the building. Show another little animated video with that. I'll talk a little about how to set this up, and as you heard there for a second, a lot of noise when you're dealing with this. So first thing you do is you got to get your generator set up right. Now, these big electrical cables are heavy. They're also dangerous when you're dealing with 480 volt electricity. So I recommend you get a lot of training with that. So you bring those over from your generator and plug them into your high voltage area of your desiccant dehumidifier. Then you want to take your gauge each and every time, your meter, and you want to meter those cords to make sure that you're getting the proper airflow through it. If you're using propane as your heat source, you want to make sure your lines are hooked up and tested. You test them with soap and water to make sure you don't have any bubbles. And you get over to where you're going to put it on gas or electric and on and off, and you see the alarm lights there, the red alarm lights on the control panel, so a lot of safety to it. And when you cut those on, just pretty much instantly you can feel the heat coming out of the outlet there, and you should put your hygrometer on that and start taking readings. At this time, without the return air hooked to the building, you should be cutting your grains from the outside relatively in half. When this thing processes air, it should cut the grains down in half. As you can see here, we got about 13.7 on your relative humidity, and this is about 100-degree day outside. So you want to test that fairly quickly and find out if your machine is running correctly. So when you're getting ready to start up and set up, you don't want to just throw these things up because the wheels are turning and it's blowing air in. It don't necessarily mean you're drying it. On your setup and monitoring too, some other important things to consider would be placement of the equipment. Been on way too many jobs in my early years where you place the equipment and you set your generators and then you set your desiccants and you run your tubes, and you only find out the next day that you can't get the doors open to the generator to put fuel in them, or you can't get the fuel truck back in there to them. A lot of times you'll be running with limited areas, particularly in downtown buildings. You can see in this picture, if you zoom in on it a little bit, that these machines are stacked too high, and in one application there, they're stacked 3 high just to get enough room to keep from blocking the entire street. In this case, the city would allow us to block 1/2 of the street, but they would not allow the other half. It's something you want to involve the fire marshal in. Make sure you don't get it all set up and then the fire marshal come by and say, no, this is not going to work. So when you're doing placement, pre-plan, all that, it's good a lot of times to draw a little sketch of it and have it available and run it around the block before you just start arbitrarily setting equipment out. Safety hazards need to be able to get in there in case you have a problem, but either medical or fire emergency, either one. And again, go by your codes and your laws when you're doing that as well. How do you know if your desiccant's performing efficiently and performing like you need it to be? Pretty much the only way to determine that is with a hygrometer. So you take your hygrometer with a reading. Now, I am not promoting any type of instrument one above the other, but this particular instrument here is a Versalis meter. I believe is the way it's pronounced. Some but it's a very good meter. This one's labeled by Phoenix, but it's also, you can get it at other places as well. But it's one of the meters that will change the temperature and humidity fast enough to deal with 5,000 CFM of air flowing. It's air flowing at probably 100 miles per hour through these tubes. So if you use a very small or different meter, a lot of times you won't get nearly the same results. So you see here you've got one hygrometer showing 110 at 23%. You got one showing 45% at 94 degrees. You got one showing 64% at 84 degrees. Now what that would tell me is that none of these are operating correctly, because even the 110 at 23% would be a little bit high. You shouldn't be at 23%. Now, the exception to that would be if you're in Lake Charles and the temperature is about 100 there and the relative humidity is about 80 and you don't have your returns hooked up, then that might be a good number. But you should cut your grains pretty close to in half with a desiccant dehumidifier. So whatever your grains of moisture, this particular meter does not calculate your grains for you, but whatever your grains of moisture are, you should be cutting them in half. It's really the only way to tell if you're being proficient with the desiccant dehumidifier that you've got. What do you need to know about power and fueling? Number one, you'll need a power source for the desiccant each and every time. And you're going to have electricity on them. Now, some of the desiccants that run on diesel or propane may be powered on 240 volt electricity, which is the same as that you'll see in 95% of your residences in the United States. So you can actually plug them in to the house or to where the stove plug is, or to where you can get a 50 amp circuit there. Not very commonly done, because once again, most houses you have 200 amps of electricity available on the power panel, and now you're going to rob 50 of those amps to run a machine. Don't leave a lot to run the air conditioning in the house and the lights and the water heater and the other stuff in the house. So most of the time you're going to use a generator. So all desiccants are going to require electricity to run the blower motors, and then as we went over a little bit earlier, your heat source will determine how much electricity you're going to wind up needing to run the entire system. Again, make sure you park it where you can get to it to fuel it. Make sure you've got availability to fuel it. A lot of people will do their own fueling and put a 100-gallon tank on the back of their truck, which is about the largest, I think it's 110, about the largest allowed by law to put in a pickup truck, and they'll run back and forth to the store and get fuel, and that works. You can make it work that way. If you're running on all electric, you're probably going to be burning somewhere around 8 gallons per hour of fuel, maybe a little more. If you're running on a dual-fired machine, some of that may be in diesel, some of it may be in propane, so it could be a combination of that. But on the worst case scenario, figure 8 to 10 gallons an hour for your desiccant. So if you're running a 100-gallon tank in your truck, you're running 10 gallons an hour, that's going to last 10 hours. You're going to be filling up every 10 hours. So a lot of people use a fuel truck or fuel service to come out and do that for them. How often do you need to fill it? Depends on how big the tank on your machine is, how big of a holding tank you got, and what your heat source is. Let's talk rental, purchase, and billing. Anytime you're using a desiccant dehumidifier, those are some things that you want to take into consideration. A typical unit with the trailer, the desiccant, the generator, everything you need to put in there is going to run probably somewhere around $130,000 to $140,000 new. You can pick up used ones in the area for a used one about $70,000 to $80,000 depending on the unit. So if it's something you're using fairly often, you'll get a good return on your money, and you decide to purchase one. Again, be sure to go over your different needs, your fuel needs, your transportation capabilities, what type of truck you have to pull with. Are you going to be DOT compliant, and those sort of things if you're looking at purchasing your own. If you're looking at rental, the time to have an agreement with a rental company is a long time before you need the unit. Don't wait till you're standing in the parking lot at 2 o'clock in the afternoon needing a Desiccant to try to start calling rental companies. So get your face in front of them, your name on paper and all that before you do that. Good person to have lunch with and talk about your plan, and so you can plan your work and work your plan. Some of the other things you might be considering when you're looking at renting or purchasing, or how you want to get that unit there, is, again, how much are you going to use it in a year's time? What's your expertise and experience level? I'm really not talking about you as the owner or the chief production officer that's expertise and experience level. You may know how to do it, but when you have a large loss, you're going to be dealing with a large loss. You're not going to be out there hooking up hoses and electrical wires and operating a piece of machinery. So keep that in mind and know what your staff is capable of doing. What are your qualifications and certifications? It's really not much of a certification to run a Desiccant, but you sure need to be qualified into higher voltage electricity and to make sure nobody gets hurt or killed dealing with that kind of stuff. Again, transportation. If you need CDL drivers, about the worst thing can happen is get 30 minutes before you get the job and the highway patrol shuts you down for 10 hours and you got your equipment 30 minutes from the job and you can't get there because the highway patrol has shut you down for different violations, and they do that routinely. It's not like in commercial transportation that they just write you a ticket and say show up next week. They actually will shut the vehicle down and you can't move it until you get the problem that they think you have cleared up. And then last but not least, you got maintenance on the equipment. So that you have to do if you buy it, to where you don't have to do if you rent the equipment. Different billing on commercial projects. Which billing systems are you going to use? Because you're not going to find these big units in Xactimate at a very favorable price. I know a lot of people use Xactimate. My personal opinion is it don't work very well on commercial projects. A program like 10M Pro or a spreadsheet or something like that works a little more favorable, but Xactimate just don't. It's not really geared for a commercial project because there's too many variables in the job. There's too many variables in the equipment to be able to use that efficiently. So keep that in mind. Maybe look at a larger job you did before and go back and recast it using Xactimate, and then recast it using 10M Pro and compare the two together, and you'll begin to see what we're talking about on it. Half of the adjusters today would want you to put it in Xactimate. Half would want it in 10M Pro or a different program like that. You take those same 100 adjusters that I just referenced and put them working for a different insurance carrier, then that half would want it on 10M Pro and the other half would want it on Xactimate. It's just a different day and a different carrier that they're working for, and what their bosses are saying they want to see as to how they want it done. And then throw a few consultants in, and they may want it on the back of a napkin. So, hope you've learned a good little bit about the the Desiccants today. If not, I'm free for you to call me at any time you have a question about one. If you decide to jump off that bridge and purchase a Desiccant dehumidifier, I'm certainly available to give a call to and go over it with you, because here at the Crest Network, we want to make sure that y'all are prepared to go out and do a commercial job and make good money on it and look good doing it and get the job done in a timely fashion. I'm Scott Tarpley. Thank you for attending.